All right, the edge of the Milky Way, a spiral galaxy. And if we look at the Milky Way, and since we're in the Milky Way, obviously, we don't have a real picture of it. So anytime you see the Milky Way, it's just an artist's rendition of our galaxy. But if we look at its diameter, let's get our pen ready. Why don't we use yellow? Make our little diameter. From here all the way to there, here on the edge, we're looking at about 105,700 light years. Light years, remember. We want to put that in perspective. That's 1 quintillion kilometers. And we can just also say 600 quadrillion miles. It's enormous, enormous distance. And that's just our galaxy. So if you want me to write that out, let's look at this. Over here, we'll put 600. That's 600,000. That's 600 million. That's 600 billion. That's 600 trillion. 600 quadrillion. There we go. 600 quadrillion miles long. So here it is in our center, right here in the center of our Milky Way, we have a supermassive black hole. We have other black holes in our galaxy too, but we have this gigantic one. And every major galaxy has a supermassive black hole, and it's called Sagittarius A. So we have a name for it. Sagittarius A, very massive. And we're about here. So we're halfway in the half of the Milky Way. So let's get a better picture of that. All right. So again, here's our supermassive black hole. And we'll talk about the arms in a minute there, because we have 4 arms in our Milky Way. You can see our sun right there. All right, so here's Sagittarius A. We should not use yellow. Let's use red. Let's use red. Okay, so here's Sagittarius A. And we're about here, let's just say. And that's halfway to the center. Halfway there. And that's about 26,000 light years. So we're 26,000 light years away from Sagittarius A and about 26,000 light years to the rim, to this edge over here, 26,000 light years. And we're just estimating this. So we're about halfway on this side of the galaxy. Now let's think of this for a minute. Let me change the color. Maybe yellow over here. So we think about the speed of light. The speed of light. And nothing goes faster than the speed of light. So it's 186,000 miles per second. Not hour, per second. That's about 6 trillion miles in a year. So if you go outside and that sunlight that's hitting you, those photons that are hitting your hand, they'll be about 6 trillion miles away in a year. Just think about that. So if we think of from the edge, from this part to where we are, 26,000 light years, let's put it in miles. That's 156 quadrillion miles. 156 quadrillion miles. If we think of Voyager 1 and Voyager 2, Voyager 1, let me get a picture of that. All right, so here's Voyager 1. So Voyager 1 and Voyager 2 are not in our solar system, although some scientists may debate that. But it took them, let's get our pen ready, keep the yellow. It took Voyager 1 and Voyager 2 35 years to get out of our solar system. 35 years. They're 14.6 billion miles away, and they're still working. Now, that's a lot for us, but for the universe, that's nothing. It's just a drop in the bucket. They're just out of our solar system. They're traveling, by the way, to a faint star in the Little Dipper. And it's going to take them, let's get the Little Dipper up. Right, there's the Little Dipper where we have our North Star Polaris. But they're heading toward a faint star in the Little Dipper, and it's going to take them, make sure we have our pen ready. It's going to take them 32,000 years to get there. 32,000 years. Think about that. And if we think about light, well, Polaris, remember the Polaris is our North Star. And it'll take light 323 years to get there. So it's 323 light years away. 323 light years away. But for us, 32,000 years. And I'll talk about other stars that are close to us. So let's go back to Voyager 1. So again, let's just say that they're here, right here. And they're heading to, let's say they were heading to the rim, how long it would take them. So they're going 35,000 miles per hour. That's what they're doing. They're going about 840,000 miles per day. Seems like a lot. And at that speed, 307 million miles 307 million miles per year. Still nothing. Still nothing. Think about how vast the Milky Way is. Remember, I told you, we're talking about quadrillion miles over here. So if we look at the span it would take them just to get to the edge, we're talking about over 500 million years. It would take over 500 million years for Voyager 1 and Voyager 2 if they were heading that way to get to the edge. Just think about that. Think of what lived on Earth 500 million years ago. We're talking Precambrian. The dinosaurs didn't even exist yet. Just imagine the vastness of space. Imagine trying to get to Andromeda, which is our closest major galaxy, which is 2.5 billion light years away. Light years, remember. So, like I said before, we live in the Milky Way, which has these four arms. And as you can see, there's a picture of the sun. There's where the sun is. And we're in the Orion Spur. The Orion Spur, which is an arm between the Sagittarius arm and the Perseus arm. And this is really our observable universe that we see. We see the stars within this little patch here. It's very hard to see stars in this area because they're on the other side of the galaxy, even though we're making inroads on that. So every star we see in the night sky is from our galaxy. We don't see any stars from outside the galaxy. We don't see any stars in Andromeda. And the stars that we do see are mostly concentrated within this area over here. Let's draw a little red over here. And again, I said we are making roads to see over here. So just imagine what we are missing. And in space terms, they're very close to us, all the stars that I'll mention, like Polaris and Sirius and Betelgeuse and UY Scuti. I mean, I can't even put them on the map because it won't even show the scale. But maybe this will help. So you can see like where we are. And again, let's make sure we have our pen ready. Most of the stars we see in the night sky are in this concentration right over here, heading this way. And again, I said Polaris. Polaris is make sure my pen's ready. Oh, we have to make sure the pen's ready. Polaris is some 323 light years away. Merak now, which is also called Beta Majoris, that's some 79 light years away. They're all pretty close, as comparable. And then we have one of the biggest stars out there, UY Scuti. And UY Scuti is some 9,000 light years away. But even that's not far. I mean, it's far for us. 9,000 light years away. And it's closer to the center. But remember when I said from where we are to the center was 26,000 light years. So UY Scuti is 9,000 light years from us. It's not halfway to the center. Again, like I said before, the stars that you can name, like Betelgeuse, some people call it Betelgeuse, is 642 light years away. Sirius is 8.6 light years away. Sirius is the brightest star in our night sky from us. Proxima Centauri is our closest star. It's only 4 light years away. So they're clustered within our observable universe, or within our galaxy. But now our question is, what is at the edge of this galaxy? Remember, where our next closest, our next major galaxy is Andromeda. But between Andromeda and the Milky Way, what is between us? And that answer is dark matter. Between in intergalactic space, Beastie Boys song, right? Dark matter. So if we think about matter, the matter that makes us and everything that we can see, matter is only 5% of the universe. Whereas dark matter could be anywhere between 25 to 30%. 25 to 30% of the universe, and the rest is dark energy. And we don't know what dark matter is. We can't see it, we can't touch it. We know it completely engulfs the Milky Way, and it engulfs every galaxy. And we know that dark matter pretty much keeps the galaxy together. So when they do models with dark matter, they know that the galaxy stays within shape. Without it, the galaxy falls apart. So we know we need dark matter, and it completely engulfs it. So here it is, our intergalactic edge, the intergalactic space between the Milky Way and Andromeda. And remember, well, in case you don't remember, in case you don't know, Andromeda and the Milky Way are heading toward each other. They will collide in billions of years from now. And between them is dark matter. And some scientists think that our dark matter from the Milky Way and the dark matter from Andromeda are actually touching now. Besides dark matter, if we think about matter in this intergalactic planetary, this intergalactic space, there could be ionized hydrogen. Hot ionized hydrogen. Of course, we haven't been to the edge yet, and it looks like our nearest Voyager 1 and Voyager 2 won't get there for a long, long time, millions of years, 500 million years. We probably won't know exactly. All right, so that's our video on the edge of the Milky Way.